Welcome to the boardroom. I am your managing director, and in this executive explainer, we are going to completely overhaul your approach to Cambridge International AS and A-level mathematics. Specifically, we are running a targeted audit on syllabus 9709, Kinematics, locking in on the differentiation and integration of kinematics. Look, examiners consistently report that this is one of the most chronically misunderstood areas in the entire mathematics portfolio. It's an area where high-value points are just left on the table, but we are going to fix that right here, right now. Today, we are going to transform your kinematics exam answers from a descriptive, low-level liability into a bulletproof, million-dollar analytical pitch. I want you to visualize an executive value meter on your screen right now, starting at $0 and capping out at a cool 1 million, which represents that elite Band 1 A-star level. Right next to it is our audit deadline clock, ticking down, and a real-time data ticker tracking your assessment objectives, AO1, AO2, and AO3. We are going to use highly structured, strategic corporate frameworks to ensure that every single time you write down an equation, you are maximizing your return on investment and pushing that meter straight to the top. Are you ready? Good.
Okay, let's take a quick look at the audit agenda to outline our strategy for extracting maximum marks from the Cambridge examiners. We're kicking off with the boardroom briefing to establish the market opportunity, then moving into deconstructing a liability, adding a structural power-up, running a live compliance audit, and finally, securing the deal.
Section 1. The boardroom briefing. Let's establish exactly what this market opportunity looks like.
Now, this brilliantly illustrates the asset valuation matrix. This is exactly how Cambridge examiners assess your cognitive domains. Look closely at this breakdown because this is where so many candidates misallocate their resources. Your core asset is your knowledge and understanding. That's your AO1. This is the absolute baseline. Can you differentiate displacement to find velocity? Can you integrate acceleration to find velocity? That's great, but that alone is not going to get you the top-tier grade. It barely gets your foot in the door. Next, you need the operational asset, which is application, or AO2. This means you can interpret relationships from text case studies and the data tables given to you in the exam. But the true premium valuation, the stuff that pushes your executive value meter into the hundreds of thousands, lies in the strategic asset, analysis, your AO3. This requires you to draw hard, evidence-based conclusions, evaluate your alternatives, and actually justify your mathematical recommendations. If you just stop at the core asset and dump formulas on the page, your overall performance is going to stall out in the lowest bands. You absolutely must push your pitch into the analysis zone.
To hit a top-tier valuation, you must demonstrate a connected, conceptual flexibility that you can seamlessly transfer to entirely unfamiliar mathematical contexts. What does that actually mean when you're in the trenches with a kinematics paper? It means you aren't just memorizing a list of isolated formulas and hoping for the best. You have to deeply understand the dynamic living relationship between displacement, velocity, and acceleration. If a question throws a totally non-standard, highly complex velocity time function at you, maybe something with a strange exponent or a weird fractional power, you shouldn't panic. You should instantly recognize that the area under that curve, the integral, represents displacement, period. You must dynamically adapt your analytical framework to whatever market conditions the examiner throws at you. You dictate the terms of the equation, not the other way around.
Moving on to Section 2, Deconstructing a Liability. It's time for the associate review, where we look at exactly where a weak proposal crashes in value.
I want you to imagine we have a high-tariff, multi-part Cambridge past paper question projected on the primary presentation display. It's the ultimate market opportunity. Let's review how two of our junior consultants handle it. On the left, we have associate Alex. Alex is a workhorse. He provides massive volumes of raw data, integrating and differentiating everything in sight. But he constantly confuses cause and effect, and he totally fails to evaluate market risks. He provides zero evaluative frameworks. His proposal is just a massive, unreadable wall of descriptive math. On the right, we have associate Sam. Sam is a fast speaker who pitches brilliant, highly creative physical concepts. She genuinely understands the physics of the kinematics, but her pitch lacks hard asset backing. She doesn't use proper headings, she skips clear annotations, and her answers are generic, totally ignoring the specific boundary conditions given in the case study. Let's go backstage right now and listen to them try to merge their assets for a joint venture paragraph. Imagine the scene. The audit deadline clock is ticking. Alex slams his hands on the table. He says, "Sam, we just need to integrate the velocity function. The formula is right there. Just dump the numbers in and we get the displacement." Sam shakes her head, pacing the room frantically. No, Alex, you can't just integrate blindly. The case study explicitly states the particle starts from rest at the origin. That's a boundary condition. If we don't set t equals 0 and v equals 0, our constant of integration is completely undefined. The examiners will rip us apart. Alex fires back. Who cares about the constant? The raw integration shows we know the core concept. Let's just define the technical dictionary terms in the opening sentence to prove we know what kinematics is. Dictionary definitions don't earn AO3 marks, Alex. We need an analytical counterargument. We have to show that when velocity is 0, the particle is instantaneously at rest, which proves a change in direction. They are stuck. Alex is trying to overload the opening with raw factual data, and Sam is desperately trying to pivot into an analytical framework, but failing to write down the actual specific textbook formulas required to back it up. Because they can't reconcile their approaches, they miss the explicit constraint of the Cambridge command word, their executive value meter plummets. They've just handed in a low-value descriptive text block instead of a high-value executive analytical pitch. A single missed keyword, forgetting to solve for that integration constant c, triggers an immediate valuation drop on the marking grid.
And this is exactly why that happens. Treat this quote directly from the principal examiner report as a harsh, non-negotiable edict from the board of directors. Failing to define your terminology before executing extended responses will instantly trigger a valuation drop. In kinematics, confusing key terminology is the ultimate compliance breach. Listen to me. Are you calculating distance or are you calculating displacement? Because those are two drastically different corporate assets. Are you calculating speed, which is a scalar, or velocity, which is a vector? If you confuse these terms in your pitch, your entire mathematical logic becomes structurally invalid. You must define your terms, state your boundary conditions explicitly, like writing down at time t equals 0, displacement s equals 0, and then execute with absolute, ruthless precision. Do not give the examiner a single reason to audit your work and find you non-compliant.
Welcome to Section 3, the structural power-up. Let's reboot this pitch. But before we step in and show Alex and Sam how to seamlessly secure a top band valuation, I need to make sure your personal academic assets are properly managed. Stop what you are doing right now, subscribe to AC Exams at the handle @ACDexams, and turn on all notifications. Hear that bell click into place? Perfect. No matter if your focus is Cambridge IGCSE, O-levels, AS, or A-levels, this channel is your guaranteed weekly board seat to secure elite grades. Don't miss a single briefing. Now let's get back to engineering this pitch.
Now, what's really interesting about this slide is the method mark strategy. This is our structural power-up. This strategy acts as your early-stage investment by securing points for your systematic process, effectively locking in academic assets even if your final numerical conclusion falls through. Think of method marks as guaranteed quarterly dividends. In the high-stakes, pressure cooker environment of an A-level exam, arithmetic errors are a reality. A dropped negative sign or a simple calculator slip might completely compromise your final answer. But if you have clearly documented your analytical framework, if you have explicitly written down the correct integral setup with its limits before you try to solve it, the examiner is forced to award you method marks. You are actively securing academic equity just by showing a flawless, compliant procedural process. Never, ever do complex kinematics calculations entirely in your head. Your working out is your corporate paper trail. It proves your due diligence.
To maximize your return on investment and overcome the roadblock Alex and Sam hit, you must execute this standardized corporate workflow sequentially. We are going to use the PEEL framework, point, evidence, evaluation, link, to rewrite the response out loud, transforming their low-value paragraph into a bulletproof A-star asset. Step 1. Identified key elements. This is your point. Decode the preamble. We extract the exact variables. Initial velocity is 0. Time constraint is 5 seconds. We document this instantly. Step 2. Apply relevant principles. This is the setup for our evidence. We state clearly, to find displacement, we must integrate the given velocity function. Step 3. Execute analysis with clear working. Here is the evidence in action. We lay out the mathematical proof clearly on the page. We don't just find the integral, we explicitly show the substitution of our boundary conditions to solve for the constant c. Step 4. Verify results for reasonableness. This is our evaluation. We step back and look at the number. If we calculate a time of -4 seconds for a real-world kinematics problem, alarms should be blaring. Matter cannot travel backwards in time in syllabus 9709. We question the assumptions, catch the error, and recalibrate. Step 5. Present in the appropriate format. This is the link back to the question. We use the correct units, meters or meters per second squared. We double underline the final executive summary. By applying this framework, Alex and Sam's chaotic debate transforms into a highly structured, undeniable proof.
Section 4, the compliance audit. Let's run a live interactive scan.
Welcome to the Live Venture Audit Challenge. I am going to display the exact exploits that destroy a candidate's overall grade. I want you to imagine a 60-second countdown timer ticking down on your screen right now. 60, 59, 58. Assessment 1 is our asset inventory scan. I am displaying a highly complex Cambridge velocity time graph. It has a jagged, nonlinear curve. Your job is to extract the highest value data point. Liability 1 triggers if you look at that curve and try to calculate the gradient to find displacement. That is confusing cause and effect. The gradient of a velocity time graph is acceleration. The area under the curve is displacement. If you mix those up, the buzzer sounds, immediate valuation drop. Assessment 2 is spot the liability. I'm putting a flawlessly calculated integral on the screen. The math is perfect, but liability 2 triggers because the candidate forgot to label the final answer with proper units, and they failed to define what T actually stands for. Is it seconds? Hours? The board rejects it for violating presentation conventions. And finally, liability 3. The text case study explicitly states the particle comes to rest at T equals 5, but the student just leaves the general equation with a plus C at the end. They fail to substitute T equals 5. They pitched a generic, off-the-shelf product to a highly specific corporate problem. Exploit found, grade penalized.
Top-scoring candidates constantly upgrade their assets by moving systematically through the descriptive, analytical, and finally, the highly lucrative, evaluative levels of problem-solving. First, you hit the descriptive level. You literally just state the governing formula. Acceleration is the derivative of velocity with respect to time. Boom, that's a basic low-yield point, but it starts the meter. Next, you upgrade to the analytical level. You actually do the work. You actively differentiate the specific polynomial function provided in the exam paper, generating the hard, undeniable evidence on the page. Finally, you push into the premium zone, the evaluative level. You evaluate that newly generated acceleration function to find exactly when the particle reaches maximum velocity, proving it by showing where acceleration equals 0 and linking it back to the original physical constraints of the question. You aren't just calculating, you are building an irrefutable legal case that demands full marks from the examiner.
So, the absolutely crucial point is asking yourself this exact audit question during every single exam to ensure your evidence being maintains total market compliance. Before you draw that satisfying double line under your final answer, you must pause, look at it critically. Have you truly deconstructed all the data hidden in the preamble? Did you question the assumptions? For instance, did you just assume the initial velocity was 0 out of habit, or did you actually verify it in the text? And most importantly, have you justified your final recommendations with hard, step-by-step written evidence? If you can answer yes to all 3, your asset is fully compliant.
Section 5. Securing the deal. It's time for the final audit. Alex and Sam have presented their newly engineered, flawless response paragraph. The math is pristine. The boundary conditions are explicitly stated. The units are perfect. And just like that, our executive value meter hits the maximum $1 million A-star mark. Your entire kinematics exam strategy rests on these 3 core corporate pillars. Pillar 1, the due diligence scan. This is your decoding phase. Read every single word of the text block. Extract your specific S, V, A, and T boundary values and list them clearly on the side of your page like a physical inventory. Pillar 2, the resource allocation matrix. This is all about timing and framework selection. Ask yourself right away, am I moving up the chain by integrating or down the chain by differentiating? Execute that choice with crystal clear notation so that even if you make a calculation error, those method marks flow directly into your account. Pillar 3, the final compliance audit. This is your review checklist. Look at your final number. Does a velocity of 3,000 meters per second make physical sense for a bicycle? No. Check for reasonableness, use the appropriate terminology, and secure the deal.
Before we adjourn this board meeting, I want you to utilize this powerful mnemonic memory hack for key terms. Think of the letters S, V, A. S for displacement, V for velocity, A for acceleration. Moving from left to right, from S down to V down to A, requires differentiation. Moving backward, from A up to V up to S, requires integration. SVA, secure valuable assets. Lock that structural architecture into your brain. And remember, subscribe to @AceTheExams, hit that notification bell for your weekly board sessions, and I want you to drop a comment below right now with your specific target grade, your qualification tier, and your subject. Put it in writing.
I will leave you with this final, provocative thought for your next assessment. When you sit down in that exam hall, are you just crunching numbers and hoping for the best, or are you structuring a bulletproof $1 million mathematical pitch? Remember, Cambridge examiners aren't just looking for a final numerical value. They are desperately searching for connected, conceptual understanding and rigorous analytical frameworks. It is time to stop acting like a descriptive liability. Step up to the analytical level, command the data, and start managing your kinematics exams with the absolute precision of a chief executive. Class dismissed. I'll see you in the next explainer.